So today we're going to see the reactions of phenol, and before we start with it, let me tell you one thing. This right here is the phenoxide ion. Okay, and like I mentioned last time, that benzene is C6H6, and when we remove one hydrogen we have C6H5, which is phenyl. Which I mentioned it before, was that C6H6 is benzene, and if you remove one hydrogen we get phenyl, right? It's very much the same as we have in our simple alkanes. For example, we have CH4, that's methane, but if we remove one hydrogen from here we have CH3, so that will turn into methyl. Now what is phenol? Phenol is basically phenyl, C6H5, but with the ring we have this structure. This ring, okay, and if we do it like this, that means that one of the hydrogens has been replaced or removed and we have something else in its place. So over here in this blue structure we have 6 carbons and 5 hydrogens. 6 carbons and 5 hydrogen, and the last thing that we do have over here is we have a hydroxide group attached over here, and we know whenever we have this hydroxide group attached, that means that it's an alcohol, right? Like for example we have C2H5OH. this is the functional group of alcohols, right? So this is ethanol, right? And we add the OL part to indicate that it's an alcohol. So this is phenol, and this OL shows that it's an alcohol as well. Another example would be CH3OH. Again, OH indicates that it's an alcohol, and we have only one carbon, so it would be methanol, right? So we're going to see the reactions of phenol, and phenol acts like an acid, so it gives all of the usual general reactions of acid that we normally have, right? Like here. So phenol behaves like an acid, and it gives all of the reactions that a usual acid gives, right? Like for example, let's take a very well-known acid, and that is HCl, right? Alright, this is an acid, and if you react it with the metal, which is sodium, so this reaction will give us this Na and Cl will combine to give us a neutral salt, plus we would have hydrogen gas produced over here as well, right? This is one reaction. Another is if we react HCl with a base or an alkali, which is sodium hydroxide, we will again form sodium chloride, which is a salt, plus in this case will form water, right? These are the very general reactions that almost all acids give: a reaction with a metal or an alkali base, metal hydroxide, right? So in this similar manner, we're going to see the reactions of phenol, right? Okay. So the reaction number 1 and 2 for phenol are going to follow the same pattern as the reactions we did for HCl, right? No, it looks a bit clustered. So now over here we have phenol, which is going to act like an acid, and we're going to react this like we did over here in this reaction. We're going to react it with a metal, which in this case is sodium, and we're going to get the same reaction that we did before, kind of like the same. So we do know that over here in this reaction, right, the hydrogen from here is removed and it's replaced by the metal, right? In the similar manner, the H over here is going to be removed, just like we had in HCl. The H will be removed, and in the place of hydrogen we are going to have the metal. This right now is the phenoxide ion, right? And now we have this. Okay, so what would be the name of this compound? And obviously along with it, just like we saw in the reaction of hydrogen chloride with sodium, which gives us sodium chloride and hydrogen gas, we're going to have similar reaction over here. We're going to have hydrogen gas produced over here as well, and this is sodium phenoxide. Now the last reaction, it's going to be similar to this one right here, HCl with NaOH. Again, we're going to have phenol, which is, in this case, it's gonna act like an acid, and we're going to react it with metal hydroxide, alkali base, and we would get similar product over here as we did in the reaction of HCl with NaOH, right? O and Na, the similar compound as this reaction. So this would also be sodium phenoxide. The only difference would be that instead of hydrogen gas, which is produced when we use a metal, we're going to have water produced since we used a metal hydroxide. That's it.